So hi everyone, my name is Tian. I am working currently as a developer at Booking.com in Amsterdam in the Netherlands. But before that I was actually living in Sydney. So I grew up in Sydney and hence my accent. So I want to start by telling you a story. When I first started working, this was in Sydney, the first job that I had as a developer, and the first thing that they put me on this, the first thing that they got me to do on this job was to spend 4 weeks in customer support. And I'm like thinking, okay, what am I doing in customer support as a developer? But this is actually a really good experience because what it allowed me to do was to look at the most difficult to fix bugs that customers had reported, and then it would force me to dig into various very esoteric parts of the code in order to figure out what the problem was. Now, there was this one problem that I had that particularly stuck in my mind, and this was a problem with a front-end JavaScript application. So someone was trying to click on something in one of the apps that we had, and then it wasn't doing the thing that it was supposed to do, because hey, JavaScript, right? And so as a fresh developer, I knew you could open up the console in your browser and see if there were any error messages, and that would ideally help you to figure out what the problem was. So I would go to the page that they specified, I would open up my console, and then I would try and do the thing that caused the error, and what do I see in the console? Cannot read property, blah of undefined. I don't remember the property anymore. It wasn't like that traumatizing, but it was pretty traumatizing that I still remembered this. Now, I don't know how many of you here have worked much with JavaScript or web development, but you're not a JavaScript developer until you see this message. Now, why am I telling you about this? You might think, well, I'm at a functional programming conference. We don't ever see any of these errors, right? But the main thing I want to think about is like, how many people are seeing this message on a day-to-day basis in their daily work? So how many JavaScript developers are there in the world? Well, I don't really know the answer to that question, but if I want to get a lower bound, I can look at the Stack Overflow developer survey. And this is an annual survey that they run to just like ask people what technologies that they're working with, how much experience they have, all kinds of things. And you're free, anyone is free to participate. So if you look at this is the graphical response to what is the technology that you're using. So it looks like JavaScript is at the very top, and from memory, I think about 100,000 people actually responded to this. So if you take 70% of 100,000, you can say, okay, we have a lower bound of 70,000 JavaScript developers that are probably running into that message every single day. Now, you'd think that with so many people running into this issue, there'd be some kind of solutions that would have come out of the community by now, and you'd be right. Like, there've been many things. I'm just going to mention a few of them. We know ES6 is an extension, or like essentially an upgrade to the JavaScript language that lets you, instead of writing functions like this, you can actually use the arrow notation to actually write functions. Amazing. And then there are also other libraries and tools that have been created. Some of the notable mentions are Flow, TypeScript, and Elm, you can see there. And they all try and solve the general problem of JavaScript being a little bit difficult to work with, especially as your code base gets bigger. Now, my talk today is going to be about Reason, and I would say that Reason is a really strong contender to be in the position of these guys there. But the question is, you might be wondering, if you haven't heard of Reason before, is what is Reason? The simplest way I can think of to explain Reason is that it is just OCaml. I'm sorry to disappoint you, actually. But Reason is actually just a syntactical extension on top of the OCaml programming language. Now, if we just dive into OCaml a little bit, this is like extremely high level, but we have the OCaml compiler, and then we can think of it as having two parts. So there's a front-end part and there's a back-end part. Now, the front-end part allows us to change the syntax that the OCaml compiler recognizes as valid OCaml code. So instead of standard OCaml, what the Facebook team has done with Reason is that they've added all this extra syntax that the compiler will now recognize as OCaml code. And the backend actually allows you to hook into the compilation process and change the compiled output. So it's that part that allows Reason to then get changed into JavaScript. Now, the main idea of my talk today is just to go over some of the reasons why you would use Reason. try not to say reason too many times because it gets, yeah. The main things I would say is they've designed it such that it's accessible to JavaScript developers. And we'll go over some of the things that make it that way. And also they've tried to make the interop story as simple and as straightforward as possible, because there's no point just writing a new project in Reason. The main value comes from actually being able to use it in an existing project. And also, just as another side effect, it happens to be extremely fast at compiling into JavaScript. So I've got these two hourglasses here. Those are the main things that I'm going to be talking about for the rest of the talk. So the first part is a tour of ReasonML, and this is mainly to highlight the things that would be unfamiliar to JavaScript devs, but I think most of us here would probably find it extremely simple, and that's actually the idea. So let's have a quick look. Now this section is a little bit long, so I've broken it down into 4 parts. We're going to look at the basics, the main data structures that Reason offers, the awesome thing of pattern matching, which I really loved actually coming from a web developer background, and also just some extra stuff. So there is the concept of immutability or mutability. And how does this work in Reason itself? There is what you define anything using what is a let binding. So you can define let bindings many, many times. And that is one form of immutability. Well, mutability, sorry. Now, if you actually wanted to define a variable in the sense that we are generally more used to, then you would define it like this. You would use a ref, and then you could then assign to the ref using the special colon equals syntax. Now, the great thing about Reason and OCaml is that it brings types by default, whereas in JavaScript itself, of course, there's no concept of types at all. Now, the great thing about Reason actually over some of the other solutions is that all things in your program are typed. So everything has a type. And the compiler actually can guarantee that these types are sound. And for the large part, you don't actually even need to declare any of these types. So it's not like Java where you have to declare the type of every little thing. In Reason, you can generally write your code and the compiler will figure out what the types are for you. So this is a big bonus. And even when you do have to declare a type, it's fairly straightforward. You use the type keyword, and then you have the name of your type, and then what that type equals to, and then you can just annotate your let bindings with the type. Now, data structures is a really interesting thing, because in JavaScript, by default in the language, you have an array, and the array can be as long as you want, and you can have whatever you want, right? And you also have an object. So there's this concept of an object, but then people use it either as an object or sometimes as a map or that kind of thing. So it's a little bit all over the place. Now, Reason actually forces you to think about exactly what you're trying to model. And then it forces you to pick one data structure that fits the thing that you're trying to model. So these are some of the options that it gives you. You can have a list. Now, instead of the list being composed of arbitrary data types, you can have a list that is just of one type. But with this, your list can be as long as you want. If you wanted to mix and match different types, you can have a tuple. But the limitation with a tuple is that the length is fixed. Now, if you wanted to model something that was like a key value pair, then you would use something that's called a record. Now, with a record, you actually have to define a type for the record. And the record has to have exactly the keys that you define. So then you can create an instance of this by doing this. Pretty straightforward, I would say. Now, the things that I've shown so far, so lists, tuples, and records, each of these are just data. There's no logic in them. They just hold data in different kinds of shapes. Now, if I wanted to actually have some functionality with my data, then Reason gives me the option of using objects. So there are 2 kinds of objects. The first type is the closed object, which is very, very, very similar to a record in that you also declare a type, and it can also have some number of keys that you specify. But the only difference is, it might be a bit hard to see, but you see that this changes to a dot there. And that is the declaration of a closed object. It has to start with a dot and then any number of keys there. Now, why would you have a closed object instead of a record? Well, in a closed object, you can actually have logic and private instance variables as well. So I can define an age for an author, and this is only visible from within my object. But then I can define something that's actually public that can be accessed from outside. And if I want to access it from outside, I use the hash notation. Now, the difference between a closed object and an open object is that the open object has to have another type as a parameter. And the way that it's declared, you see it's got the 2 dots at the first line instead of the 1 dot. So the 2 dot indicates that it's open. And it's basically saying whatever type T that I give to this open object, as long as it has a name, I don't care what else it has. So it's a little bit more flexible than a closed object where it's all fixed. And similarly to a closed object, you can also have logic in it as well. So I can give it a closed object that has a name and a right, and it's happy because we have a name. So it doesn't matter that there's a right there as well. And then I can implement it very similarly to how I showed earlier. So I just have a private variable, I have a book, and then my author has a name that people can actually see, and then I can actually write some of the book. That's a very, very simple example, but this is actually showing you logic as well. And because of this, because we have this open object, we can then define something as calling that open object. So we can have anything that is named, and we don't care what exactly that thing is, but we know that because we're asking for a named, we have a guarantee that the name field would be there, and that then therefore we can call it. So all of this stuff comes with the language for free. There's no need for me to actually download any libraries or do any funky stuff. All of this comes built in with Reason. Now, the cool part actually is what I'm going to get to now, which is variants. And this is very, I'm sure any of you who have worked with functional programming languages for any amount of time would have seen this. So it allows you to define a data type, which is something or something or something, and so on. Now, so I can now define something like this, and this is really good for, say, defining various states of my application. And this on its own is pretty good already, but the great part about it is when I actually start pattern matching on it. And pattern matching is something that I absolutely love about functional languages. And what you can do with pattern matching is what you would expect. But this part is, I would say, can be an epiphany if you've never seen it before. So I can have an instance of my variant before, and then I can match on that variant. So then I can look at all of the various cases and then choose to do stuff based on what the particular case is. Now, the great thing about this is that because the compiler knows all the different branches of the variant, then when it compiles, it will tell me if I've missed one of those variants. So I'm never going to get into a situation where I've failed to catch one of the possibilities that I've declared earlier. So that's really, really cool. Now, this pattern matching, the great thing about it is that it's not actually restricted to variants. You can actually pattern match on all kinds of things. And so this is a very typical example of pattern matching on a list. So I can match the empty case or the standard case. I can also pattern match on different variables. So for example, this is a very, very simple case of the fizzbuzz. So this is how I would actually write fizzbuzz, right? I have 2 booleans, I have divisible by 3 and divisible by 5. Now, instead of writing a whole bunch of if else, I can just explicitly list out all of the values in this. It's like essentially I'm reading off the values in a table and then matching them to the outcome. So I can easily see this in a graphical form. This is really, really cool. And again, the compiler will also warn me if I've missed any case there. Special mention of a variant is, and this is definitely no surprise as well, is the option variant. So this is where you have the, like in other languages, it can be like, it's a maybe or an optional and so on. But in this case, with this, I can essentially eliminate the bug that I showed at the beginning, among other bugs, of course, but it's a pretty big deal, I would say, because that's one of the most common things that you see in JavaScript. Now, a little bit about the extra stuff. So that was most of the really cool stuff. One interesting thing I noticed about Reason is that there is no concept of importing or exporting stuff explicitly. So in JavaScript, you have to like import blah from blah, or you would require, depending on the kind of modules that you have. In Reason, every Reason file that you have is automatically a module, and every let binding inside of your Reason file is automatically visible to all of the other Reason files. So you don't actually need to explicitly say, oh, I want to import this reason file and that reason file and like those bindings from that reason file. Everything is all available by default. Now, if you think that's like too crazy, you can actually define a reason interface file, so .rei, and that will let you specify just a subset of the bindings that you want. Now, I don't know if any of you have worked with JavaScript much, but back when I was working on a particularly large project, one thing that we'd always argue about in our team was how to structure our directories. So people would be like, no, should we have it as like source/components and then divide it up by like the component, or should we divide it up by all kinds of like different ways of dividing up the thing? Now, because here, and the reason that that was a huge pain was because you'd have all of those explicit imports in your JavaScript files. You would say, I want to explicitly import something from this path. And as soon as you shuffle things around, you then have to change all of the imports, and it's really painful. Now, with this, you can actually shuffle around stuff as you like because you're not importing anything. And the great thing to think about it is that your file structure is a tree, but your code structure is more like a graph because you have things calling all over the place. And now you've kind of decoupled that instead of trying to force one to be like the other. How does reason work with other functions and other values in other languages? It's using an FFI, and the way that you declare it is you just declare the signature of the thing or the type of the thing that you're trying to use from the other language. And you do that by using the external keyword. So this is just an example from if I want to use a function from C. So this is the value that I'd be using in my reason code. This is like a signature, and then that's the name in the other language. So I've just talked a lot about reason and its syntax, and you might be thinking, okay, all of this stuff is like fairly simple and straightforward, and I can more or less understand what's going on as I'm talking about it. And I'd like to say that that is the point of the language. They've made it very, very similar to JavaScript in order to lower the barrier to entry for people actually using the language. And so the fact that it seems really simple is like a good thing. Now all of that stuff though is not particularly useful if I can't use reason in my existing project. So the next part I want to talk about how this interop story actually works. This part I've divided into 4 sections as well. So firstly about reason and JavaScript, like what the connection is, what's going on there. How do you use JavaScript libraries in your reason code? And then the other way around. So how do I actually use my reason files in my JavaScript? And then what you can actually do from here with all of the knowledge that I've talked to you about today. So let's go. So remember I showed this slide earlier. So we had the OCaml compiler, and there was a front end and a back end. So the first part that I've just talked about now is all to do with the front end part. So all of that funky syntax that you saw earlier, all of that was a bunch of work done on the front end in order to get the compiler to recognize all of this new syntax that we have for reason. Now this part, I'm going to be talking about the back end, more or less. Now, what is this? This is BccalScript, but what BccalScript is, it's a new backend for the OCaml compiler. So it's like there's actually already a thing that will take OCaml and turn it into JS. I think it's JS of OCaml. But the deal behind BccalScript is that they've tried to integrate it as well with reason. So it's supposed to work seamlessly as one toolchain. Now, what does it do? It's going to take your reason code and then output it as JavaScript. And the output of JavaScript is generally relatively readable. So how does it actually work? It will take each reason file, whatever it happens to be, like index.re or component.re, and then it will turn it into the corresponding JavaScript file. So it'll be like index.js, or you can actually configure the syntax, and usually it'll be index.bs.js. But the idea is that one reason file maps to one JavaScript file. And then, because the JavaScript file is just JavaScript, then you can actually use it in the rest of your code base, because the rest of your code base doesn't know, it can just see the JavaScript. And as I've said, they're relatively human readable, so this is actually kind of an escape hatch. If you're first introducing this to your project and something is breaking in production, you can actually go and debug it fairly well. That's one point. And also you can actually go and directly edit the generated JavaScript file in case someone doesn't actually yet know Reason and like doesn't want to get their head around it just at that moment because everything's on fire and you want to fix it. Yeah. So what do you actually need to get this to work? You just need two things. You need a configuration file called bsconfig.json, and then you need to download this tool via npm or whatever your favorite package manager is, called BSB. And the bsconfig, don't sweat, it's actually very, very straightforward. This is the smallest bsconfig that you actually need. So you just need to say what the name of your project is and then where your Reason files live in the relative to the root of your project. So in this case, source is where I've specified. This is actually all you need in this config file. And then how do you get the tool? Well, you just use npm to install it, and then you run the make world command. And you can use -w in order to get it to watch the files as you're changing them and then compile them as you're making changes. So what does this actually look like? It's very, very straightforward. I've got my existing project and there could be a bunch of stuff in the source directory already. I've got a package.json because I have a JavaScript project and we all have that. And I've just added this one tiny little file. So the setup part is actually very, very, very minimal. And what does this actually mean? Just with those steps and what I've already spoken about, you can actually already start writing entire JavaScript applications in Reason. So you can actually go and spin up a new project and start using this and write projects there. But how do we actually do the interop? Because inevitably we're going to get to a point where we need to use stuff from both worlds. And this is where it gets interesting. So remember what I was saying earlier about the foreign function interface. So I can declare stuff from other languages using this kind of syntax. So the way that you do it in Reason, it's specifically designed to work well with Bccal. So you use this thing, this @bs.val. So this is one type of a Bccal directive. And this is, I would say, the simplest form. So this is saying, I want to directly import this B2A, which is in the global namespace, and it has a signature from string to string, and then I want to use the same name in my local file. So this is the simplest example. There are other examples where you have to import, you want to use something that's within another object, or there's sometimes you want to require a module and then instantiate that thing and then use a field from the thing that you created. There are also directives for that, but this is the simplest example. And after I do this, I can then, from my Reason code, I can just call it directly and the compiler will be happy. Now, as I said, there are a whole bunch of other directives that you can use. So there's bs.module, which allows you to require another module. And then there's bs.scope, which allows you to use something that lives on another object. And you can combine these as well. You don't have to just use the one. And then this is the one that allows you to simulate the new and then creating an object, like say, so you can actually say, I can use module to import something, then I can use new to actually instantiate the thing, and then I can use scope to actually grab the thing off of that. And then Unwrap is another example where sometimes you have functions in JavaScript that accept arguments of different types. And then the body of the function will check, if you've given me a string, I'm going to do something. If you've given me something else, I'm going to do something else. So Unwrap actually lets you actually import such functions by unwrapping those two or more different types. And there are quite a few more of these. I've just given you some of the most commonly used ones, but there are many more of these. And at the end of my slide, there's actually a link where you can find more information about each of those. But you can imagine that if you're writing these, sometimes these can get really complicated. So the first thing I would advise you to do is to check for existing bindings. So by bindings, I mean literally just this, the BS stuff. That's the binding. So how do you check for existing bindings? There is the Reason package index or redex. You can find it at redex.github.io. And there are already bindings, as you can imagine, for a lot of popular libraries there. But if you don't find it there, then you're going to have to write it yourself. And if you do find something there that you can actually use, then you need to add it to your config file under the BS Dependencies section. So this is fairly straightforward to do. You have your minimal BS config, and then you just have a new key called BS dependencies, and then you can just have your array of dependencies. Now it's really important to remember though that the things that you're adding here are just the bindings. You still need the original library. So if I'm using React, for example, I need to get the original React library, and then I need to get the bindings before I can use it in my Reason. Okay, so that is how we use JavaScript things in Reason. Now, how does it look for the other way around? So again, we go back to the BS config. And this is what we've just seen. So this is stuff that we're already cool with. Now, the main idea is that we need to generate JavaScript from our Reason, right? And then we need to generate it in such a way that the rest of our JavaScript can actually call the generated JavaScript. And the way that you specify that is by using this thing called package specs. So this allows you to control the output, the outputted JavaScript. And there are some other keys that you can tweak here. But the main thing to point out about this is the module specifies the actual module type that is output. So JavaScript has different module types. The most common ones are CommonJS and ES6 modules. So you can control which type of module that you want outputted so that it will work with the rest of your project. For example, if you're using an ES6 module system. And then in source just outputs it alongside the source file. That's it. And this is what I mentioned earlier when I said that you can generate one JavaScript file from one Reason file. This allows you to control the suffix. So if you specify it as just .js, it can be a little bit hard to figure out which ones are generated JS and which ones are like human-written JS. So the recommended ending is to use BSJS, so Bccal JavaScript. As I mentioned earlier, there are different module types that you can output. The 3 that are supported, or 2.5 that are supported, are CommonJS and ES6.
No require?
Sorry?
No require JS?
No. I'm pretty sure that was supported. Like last time I did this talk, it was, but then I checked it a couple of days ago and it wasn't, so I just removed it.
Well,
yeah, it's a little bit.
Probably for the best.
Yeah, I will. Well, I can show you some stuff after the presentation, but yeah. So that's actually it. So all you need to do is you need to specify the module type and then the suffix name, and then you can import the generated JavaScript file as you would any other JavaScript file in your code, and then it will work. Now, how do you actually use all of this stuff that I've told you today? There are actually 2 things that I can suggest. The first thing, and I would say the most straightforward thing, is to just spin up a new Reason project and write a new Reason file from scratch. So this will allow you to get used to the syntax, the compiler, how all of that stuff works. So generating the JavaScript, what does a generated JavaScript look like? Then if you're feeling brave, you can actually go ahead, take any existing JavaScript project that you have, and then add the BS config, add in your Reason file, and then try and use that Reason file in the rest of your project. The other thing I suggest trying to do is just bypass all of that, go into your project, and then try and convert a file into Reason. And I can guarantee you that you're going to learn a lot in the process, but actually you may not actually have to change a lot of stuff in your code. Because the syntax is so similar, you can actually change the extension and then get the compiler to tell you what exactly is wrong and fix all of those compiler warnings. And generally it will work, so give that a go. But this will be the first step for you to actually go and start using Reason in your existing projects. So those are the 2 main ways that I would recommend people to go ahead. Now, I've gone through the accessibility of Reason as a language to JavaScript developers. I've told you a little bit about how the interop story works both ways. Does anyone have any questions before I wrap up?
Reason and ReasonML, are those 2 different things? Or those
no, they're the same. They're the same. So ReasonML is like the official, I would say, name, just to indicate that it's related to the ML family of languages, but a lot of people would just call it Reason. Yep.
I saw on the Redux package thing that there's a lot of bindings for React.
Yep.
Does Reason is it designed for React, or does it work with Vue or Angular or any of the other?
No, it's not designed for React, but the idea is that they want to make it really easy for people coming from React in order to use React in Reason. So they've tried to make that as seamless as possible. Yeah.
Gotcha.
Yep, exactly. So Jordan Walker, I believe, he was the guy who created React, and also he's working on Reason as well at the moment at Facebook. So,
Okay.
yeah. Any other questions?
How's the debugging story? Like, is there possibility of attaching a debugger and being able to see that, or do you have to traverse through the generated JavaScript code?
Yeah, so as far as I'm aware, you would have to debug in your browser, and you'd be debugging the generated JavaScript. I don't think you can debug the Reason itself.
Because
That's where I'm getting at. Yeah, like some sort of symbolic stuff that could somehow point you to where your Reason code is and get step through or something like that.
No, but then because you have one file mapping to one Reason file, you'd automatically know exactly where in that file it is. And then because your file will be made up of various let bindings, then you could actually look at where that is in your JavaScript file, and it's fairly easy to look back there. So, but it's
gotta read
to reverse compile it back in your brain.
Yeah, pretty much.
And one of the things real quick is that you had option types, and are those boxed? Do they incur runtime overhead, or does it essentially at runtime turn into a nullable value?
I'm not 100% sure about that. I suspect it's the latter though, but I'm not sure.
Here's one weird case: is if you have nested options or something, right? That's always a weird case to try to deal with whenever you're trying to nullable things. I'm curious if
there is. Yeah, no. So there is, because JavaScript has this unique situation where it has null and undefined, and various other things as well. There are special cases for dealing with that. I just don't know them off the top of my head right now. Yeah, but that is a real issue though that they've tried to deal with in the Reason side and also in the buckle script side as well.
It can also affect JSON encodings from backend and stuff.
True.
Make sure
Yeah.
Yeah.
Yeah. I think
Yeah, so when you were showing the type definition, I came to mind, it looked like when you mentioned it was type inference was involved there. Is there support for dependent types too, or?
What do you mean by dependent types?
I mean,
just to be clear.
I'm thinking an Idris.
Can you use one in a type?
Yeah.
Can you
say this value has the type of one?
Yes, depending on the value.
Oh,
or
no,
this
I don't
type
think
is
you
A
can.
plus B.
Yeah, I don't think you can. Yeah.
It's a relatively rare feature. I was just curious if.
Yeah.
So it's more like the ML style of type inference, right? Okay, cool.
Yep.
Is there any sort of managed effects, or is it just side effects? The type system doesn't really think about side effects; you just do them.
Yeah, so I think that depends on what you're writing in. So, for example, I think you were referring to how you're thinking about how it will work in Elm, right? You have So the thing with Reason is that I guess it's not specifically necessarily designed for writing UI applications. You can write anything with them with Reason, but if you use something like React and Reason, then they have this. The way that they do it is that you trigger an update, and then that tells React to do the update. So I don't know if that's the effects thing that you mentioned.
Maybe you're asking
It's not in the type
at
system.
the type level.
Right.
Well,
Pure Script has IO and stuff, right?
yeah, I don't think it has that.
It also doesn't have higher kind of types than ReasonML, I would assume. So that would
You wouldn't. Yeah, I don't think you would use it normally, anyways. But if you wanted to, update the state of your application, you need to specify the various types of actions that will update your state. And so then it will actually force you to handle all of those various types in order for you to actually make that. And what you can do is, because I actually made this using Reason and React, you can either trigger an update that will update the state and will change the UI declaratively, but you can also trigger an update with the side effect. But then that side effect, you can pretty much do whatever you want there. So that's like, I can modify like the history or whatever other thing. So I wouldn't say it has as good of a managed effects story as Elm.
Is there something like an IO type or anything like that? Because like maybe you don't have that kind of types, but I could sort of imagine, because you do have polymorphism, right? Like you can have type parameters on things, right? So I imagine you could probably roll some sort of IO type if you really wanted.
I feel like there might be something in the OCaml library, which you can actually just use in your Reason, because like it's all the same thing. So yeah, so I don't think Reason hasn't really tried to reinvent the wheel in terms of like all of the libraries and stuff. It's just changing a whole bunch of the syntax to make it accessible, but you can also use everything that's already available in the OCaml ecosystem.
Oh, okay.
So I suspect that will handle that case.
Yeah. There might also be performance overhead trying to like serialize all your stuff to IO and then run that in JavaScript runtime. So.
Yeah. Cool. Any other questions? No? All right. So just to recap everything, because there was a lot of stuff there. We started off by looking at the typical JavaScript developer experience. Then we talked a little bit about Reason and about OCaml. Then we went fairly deep into the guts of the Reason language, so the various things that you can actually do. And then we looked at the interop story and how you can actually get started using Reason in your project. Now, I'd like to say that this is the end of my talk, but also I would say that this should be the new beginning of a different way of writing front-end applications that allows us to focus on actually solving things for users and for customers and solving real problems rather than banging our head against stuff that should be handled by the language already. Thank you. So you can find the slides now at this link. And as I said, right after this slide, there's a whole bunch of links to resources and stuff like that. So there's stuff about the BS config syntax, there's stuff about the BS directives and introductions to Reason and OCaml and so on. So check it out and yeah, come find me at the conference or ping me on Slack or whatever. Cheers.